Now we're going to switch for the third talk, exploring scaling new technologies that improve work. And to do that exploration, we're delighted to have Ben Armstrong with us. He is the executive director of MIT's Industrial Performance Center, where he co-leads the Work of the Future initiative. In his research and teaching, he examines how workers, firms, and regions adapt to technological change. So we're very excited to hear your talk, Ben. And FYI, Ben was teaching yesterday afternoon. He hopped on a flight, landed this morning at 6:05, and here he is now. Ben?
Thank you. Thank you so much. Just a quick story to get started. So there's a large multinational corporation that has a big HR organization, and for each of their managers has an HR business partner that they interact with. So if there are any challenges with someone the manager is supervising, they need to take leave, or they need to hire someone or fire someone, they go to that HR business partner. And for each HR business partner, they handled about eight managers. And that was the job for a long time at this company. For an HR manager, you would handle all the human relations issues that would come up for your 8 people. Now, this is a big multinational company. It's a tech company. They said, how do we make this process more efficient? And what their goal was to take that one HR business partner that currently served 8 managers and see if they could help that person serve maybe 12 or maybe 15 managers to make that person more productive. And they had what they thought were a suite of technology tools that could help them do it. So they analyzed the HR business partner's workflow, and they thought, okay, about 60% of this person's time is spent dealing with complex problems, real human issues at the organizational level. But about 40% of the time, that person is handling really routine questions that they're answering over and over, and that work is really drudgery. So they thought maybe we could use some kind of chatbot. At first, it wasn't ChatGPT, but eventually it was a GPT-based technology. And they thought maybe we could make this much easier for managers. They could query the chatbot instead of going to their HR business partner. So what they did was they introduced this, as a company-wide email to managers. Here you go. There's this new chatbot for all of your routine HR questions, and you can go to your HR manager for the more complex questions. Now, when this introduction, given all of your experiences, when this introduction happened, how do you think the managers responded? Any ideas? You said they didn't like it. Why don't you think they liked it? No human interaction. Any other ideas? Okay, so the first try, no one used it. So they didn't like it. They really voted with their feet or their calls. They just kept doing the same thing that they'd always been doing. So this was a process that had been so ingrained that even though the technology was introduced, even though the technology was pretty good, this is a company that's quite advanced in developing and deploying these tools, the uptake of the tool was actually quite bad. So the company went back to the drawing board and said, okay, what did we get wrong? How do we really deal with these ingrained business processes? So what the company did, which I think is quite bold and makes for a better twist to the story, was the company took away the HR business partner from the managers. They said, all you have now is the chatbot. All you have is the interface. You no longer have a dedicated HR business partner. What do you think the managers said now? Any ideas? Sorry, I heard someone say. I hate it. They were furious. They liked their HR business partner. They liked to be able to have a human face to go to with questions. So even though this technology, even really before they tried it and tried to get it to answer their routine questions, they had reacted very negatively. And in surveys that the company did, the approval score for the HR department went way down with this experiment. But ultimately, to their credit, the department stuck with it, and eventually the approval went way up. And it went up for a few reasons. One was that the routine questions, the typical questions that a manager would have, could be solved easily through the bot, and the bot could actually route the person's questions to a specialist. And the HR managers actually liked it because not only did they avoid the drudgery of their work, having to answer these routine questions, but they also had a new type of job. They were specialists who were now pooled and now had questions that were much more complex and interesting for them to resolve. So ultimately, what I think this case helps illustrate is the human challenges of deploying these types of technologies like Patty was talking about earlier, but also the need to redesign work as these technologies are being integrated. So what this company did wasn't just re-engineer a process, but it also redesigned the job for an HR manager. And the redesigning of the job not only made that job better, but also made the process work more smoothly for this company. So today, I want to extrapolate a little bit from this example and talk about three main themes. One is what's different about generative AI versus past technologies that are meant to change work and redesign jobs. We've talked about redesigning jobs or augmenting work in terms of industrial robots, in terms of computers and robotic process automation software. So really we want to hone in on what's different about this set of technologies. The second piece, I want to introduce you to some early evidence of how these technologies are affecting workers both in the lab and in the field. And then finally, and Patty covered this so well, I don't even know if I need to deal with this third point, but the known unknowns of how these technologies will play out in the workforce and in the economy. So to get started, here are the three big questions for my research right now, which I'm conducting with colleagues in the interactive robotics group at MIT. We have a group of about 40 companies that we're working with to understand their early uses of generative AI in particular and large language models. And our goal is to understand how their experimental deployments, their pilot uses of these technologies are affecting job quality for the workers whose tasks are affected. So let's say if they're deploying this in a customer service environment, like I'll talk about in a moment, how are the customer service jobs actually affected? What new skills do they require? Are their wages changing? Those types of things. And then the second question, which is really a bigger picture economic question, is what should we expect in terms of productivity and economic growth from this technology? There's been a lot of, I would say, speculation about the potential impact of new AI technologies, generative AI in particular, on productivity growth. I'm much more skeptical, and I'll tell you why in a bit. And then I'll share a bit from the MIT perspective, but I'd also love to hear others in saying how do we think about preparing our students, and then how might that translate into how companies can prepare their workforces. Okay, so just to give some historical context of how this time might be different than the past. So in 1960 in the United States, and this wasn't just an American phenomenon, there was a widespread anxiety about jobs being displaced due to automation, due to computerization. So there's a series of hearings in the Capitol building in the US Congress, and the hearings sound a lot like today, where there are people who don't quite understand what the technology is, but are really worried about it, and they are concerned that the jobs that they have or their friends and family have will no longer exist because this technology will have replaced it. And in this series of hearings, it's kind of funny to read, or at least comforting for me to read, look back 60 plus years ago, that there were a number of technology experts and economists who said, really, our economy is doing quite well. There's a lot of prosperity. There's low unemployment. The concern really isn't the displacement of jobs. The concern is more about overall social and economic progress. So one of the real, the great voices of this era and later was actually from organized labor, which was quite pro-technology at this point in the United States. And their argument was that the concern isn't necessarily whether there will be more jobs or fewer jobs, but how we shape the contribution of technology for social and economic progress. The idea was that there was a way that technology could improve lives and improve work, and then there was a way that technology could de-skill and make work less and less pleasant. And this was actually a choice. It was a policy choice, and it was a choice for organizations. So I think this is a really important lesson, A, that these questions aren't new, that they've been around for a long time with other technologies, and B, that we have a sort of playbook for how to think about them. Also, I take comfort in the debates of the 1990s and 2000s around productivity coming from computers and the internet. So some of you might remember there were a lot of predictions about when personal computers were introduced into offices that they would dramatically improve productivity the way that the electrical grid did, or that the steam engine did, where you saw a big stepwise gain in productivity and prosperity. But instead, what happened with personal computers was that we saw very slow and steady growth with productivity. And this led Robert Solow, the MIT economist, to say that we see the IT revolution everywhere except in the productivity numbers, because all the expectations we never lived up to the expectations, and that became known as the productivity paradox. Same paradox goes for the internet. Predictions were that the internet would dramatically improve productivity. Think about the improved productivity of writing an email versus sending a letter or even making a phone call. And yet, those individual the task level productivity improvements did not translate into anything widespread. So what I'll argue today is that we're actually, potentially going to face a similar productivity paradox with AI. So here are kind of some summary arguments that I'll come back to in a moment, but just I want to churn right along. So I mentioned the research that we're doing with companies to try to understand on the ground how are these tools being used today. And we've interviewed quite a few companies thus far, and the ways that they're using these tools fall into really three buckets. The first bucket is, as you might expect, taking an existing task that the company does, like, let's say, support managers with, for their HR questions, and how do we do that faster or do that with fewer human resources? So that's like a pure productivity application. And what I've been surprised to find in a lot of these companies is that they're not that excited about these technology tools for productivity. And I'll explain in a moment, but that particularly generative AI tools aren't as primed to make productivity enhancements as they are to do the latter two activities, like decision support and innovation. And one of the reasons why companies that I don't think have leaned into the productivity applications as much is because there are all these other tools, like robotic process automation, like other specialized software, that are designed specifically to be productivity tools that are very robust, and a lot of companies haven't gotten the most out of those tools yet. So before they move on to generative AI, I think they want to scale up their use of other tools that are made more specifically for these purposes. And here's one of our early representations of where generative AI is different from those other tools like RPA or just taking industrial robots, which is another area that my colleagues and I work on. So let me step aside for a second and just point out. So if we're plotting this along, excuse me, where's my laser? I don't have a laser. So if we're plotting this along, thinking about the flexibility of a technology, so essentially the ability of a technology to adapt to different environments, to perform different tasks on the x-axis, and its robustness. And think about, I know robustness has an engineering definition, but if we just think about the reliability of a technology to do the same thing that you tell it over and over and over again. So if you give the technology the same instruction twice in a row, you want it to be able to respond the same way. And with an industrial robot, for example, a robot arm, it's very good at that. That if you give it the same code, it's going to do the same thing over and over again as long as its tooling is okay, as long as it has a reliable power source. But if you're asking it to do different tasks, that's actually very hard for it to do without being reprogrammed and being set up and tested in a new environment. So with industrial robots, which we thought of as kind of a classic automation technology, we think it's highly reliable to do repetitive tasks, but not very flexible. So where you get the flexibility in robots is from human engineers. So human engineers can reprogram robots and kind of add their own knowledge to make that robot more flexible. So if we think about technologies in this upper left quadrant, the role for human workers is really to add flexibility. That's something that humans are really good at. Now, if you think about generative AI, and I think Patty explained it very well, it really has inverse characteristics, where you can give it any type of prompt. You give it prompts in different formats. It can understand different languages, and it's going to give you a response, but that response might not be reliable in terms of trustworthiness, and it might not be the same response if you give it the same prompt twice in a row, because it's a probabilistic model. So the issue here is that high flexibility, low reliability. So the role of the human worker in the context of generative AI is to add reliability and robustness, right? A very different task than adding flexibility. So this is where we see a really different challenge for workers, and we see very different challenges for job quality when we're integrating this type of tool. So you could think about a very creative process of thinking how do you redeploy a robot, but a not very creative process of how do I fact check the output of an algorithm? Do I want to spend all my time, instead of writing, actually doing fact checking or editing of an algorithm's work, right? There are very different implications for how you set up that job. Okay, So now I want to go into some of the existing studies, kind of what we know thus far empirically about how these technologies can affect work. And coming back to the productivity paradox point. So here are two early studies. I'm going to point without my laser, but just to walk you through it. So on the left, this is a study from some great MIT economics graduate students who published this in Nature a few months ago. And then on the right, actually, we have a lot of Eric Brynjolfsson love in the house today. This is Eric along with Danielle Lee, who is an MIT colleague. On the left, this is a study of writing press, essentially having individuals write press releases with or without assistance from ChatGPT. So it's a lab experiment where you're asking people, can you essentially write a short document about a topic, and then they had a random subset write it on their own, and then they had another random subset write it with ChatGPT support, essentially having a drafting partner. And then they took all of these anonymized documents and they gave it to a group of people to evaluate the quality of their work, subject matter experts to evaluate the quality of their work. And what they found was actually a really positive story for the ability of ChatGPT to augment the quality of work. So you might see that just the summary headlines in A, so the time taken decreases. That's for the group that uses ChatGPT. They can do this task faster, and they can do this task at a higher quality. And on the right side, we see a similar finding from customer service agents. And what's important about this study on the right is that this is the first time that someone has actually studied the use of these tools in the field. So this is in a real company that's actually doing customer service calls. It's a technology company. This was a call center environment. And what they found was that they trained some of their customer service agents with a ChatGPT-like tool that helped them figure out what the best response would be to the customer complaint. They trained some people on that tool right away when they started. That's the red line. And they trained some people with that tool 5 months in or 6 months in. That's the green line. And what they saw was that the group that was trained with the generative AI right away became highly proficient at their job very quickly. So their learning curve became much steeper, and they performed, this is on the y-axis, call resolutions per hour, they performed like a pretty experienced customer service representative only a few months into their job. Now, what I find really interesting as a result isn't that this technology kind of supercharges or makes you better than an expert. Really what the red line folks do is they just become good at their job quicker. But that if you introduce this technology later on, when someone's developed their routines and they figured out how they want to do this job, the effect is far less. It's actually not even statistically significant. So there's a real implication to when this intervention happens and how we integrate it into training from this data. So some of you might be interested in how these results, the implications they have for skills, the skills that people need on the job. I mentioned a little of what we think about the skills related to flexibility versus reliability. There are some helpful findings here. So on the left, we're going to go back to that study from press releases. They found that less skilled individuals, so individuals who weren't as good at writing, actually benefited more from ChatGPT than skilled writers. So this is actually quite different from past technologies. So a lot of studies of computing, for example, show that those who are highly skilled or who have more education typically benefit more from computing technologies. But here, and this is consistent across multiple studies, it seems that people who perform below the median, so less skilled individuals, actually benefit more from access to these types of tools. So there's a big difference, and in some ways a good difference that we're actually helping lift up the bottom of the distribution. Just another way of looking at this from a study of law exams. So in this study, a subset of law students was given access to a ChatGPT-like tool to help them. It helped them on a multiple choice, but not really on the essay. And here is a helpful way of visualizing who it helped the most. So on the X here, this is how the law student did when they weren't able to use an AI assist. And so the bottom quartile of the law students, they benefited a ton, right? They became 30 to 40% better when they used the AI assist. But the top 20%, they actually got worse, right? And, top 20%, the only way you can go is down. But really, there's some implications and kind of some lessons from the things that Patty was talking about and that Kathleen was mentioning around skill degradation, that perhaps relying on these tools in certain high-stakes contexts could make you worse than you would be at a task if you were unassisted. And now, this is the third. I want to get into the third category, which I think the most interesting of the three is how might you use these tools to develop new products, new ideas, to innovate. And there was an interesting study. I've been working on this for a little while, and then I picked up the newspaper one day a few weeks ago, and I saw this headline: MBA students versus ChatGPT. And whatever you want to say about MBA students. I don't know if they have the same reputation in France as they do in the United States, but my bias was with the business students, that I thought the business students would, of course, outperform ChatGPT at innovation. That was not even really a question, that human creativity is still going to triumph over an algorithm. And then I read the article, and the article was really concerning. It was saying that the students did really poorly, and that the algorithm was found to be much better at coming up with new business ideas, new product ideas. And it was head scratching. So I went and I read the paper, and it turns out, and I think this is a cautionary tale for a lot of news media about this topic. It turns out that the article just got the news article got the academic article wrong, that the academic article doesn't really find that MBA students are better. And I'll show you a few data points. So really, here's one of the main plots about saying the quality of human ideas versus GPT-4 ideas. There's no real statistically significant difference. Yes, there's some slightly higher purchase intent. That's how they're measuring quality from the algorithm. The human ideas are slightly more novel, which you might think is actually more innovative. But then when you look at the ideas themselves, that's when it kind of falls apart. Is the ideas themselves aren't really that interesting or innovative at all. They're coming from the algorithm, right? A compact printer, right? Is that really some breakthrough to have a compact? There's actually a printer company called Compaq, right? So it's not that the standard that we're using for innovation here is just kind of backward and I think kind of unravels some of these findings. So sometimes I think we're looking for surprises from these algorithms, and if we press a little harder on the evidence that's being presented, we'll find that it doesn't really push that hard against our priors. Okay, so finally, I want to dig into what I think what I'm interested in, I hope a lot of you are interested in, is how these tools might transform the quality of our daily work, the types of tasks that we find meaningful, that we will be able to reduce the tasks that we don't like as part of our jobs, et cetera. And one of the interesting pieces from both of these studies was that the nature of the job changed in both the writing of the press release and the job of a customer service worker. So the customer service workers, for example, became more productive, clearly, and they were generating more profit for their firm, but they were also in a much more frenetic environment, right? They were on calls for much shorter, they were going between calls, and it was much faster paced. It wasn't the type of idea where you might have had to pause for a hold. So it's unclear, it's clear that in this study, turnover went down, the customer service representatives stayed in their job for longer, but the nature and pace of their job really changed. Similarly, on the writing task, you saw that editing, the writers spent a lot more time editing, a lot less time rough drafting, and actually slightly less time brainstorming, right? So they were actually using that maybe creative faculty a little bit less as part of the writing. As someone who really enjoys the writing process, I'm a little bit worried that this might become a more standard way of approaching a writing project. And I, for one, will certainly avoid it in my own process. And then, this is a new study from a colleague and collaborator of mine, Kate Kellogg, as well as others. And I think, Kathleen, you mentioned the BCG work that was recently published. So this is a collaboration with some BCG consultants, and it's received a lot of media attention. And what they did was they took a lot of consultants who are supposed to be trained in coming up with new ideas, in accomplishing analytical tasks, and they did a similar experiment to the other ones I've described. They gave one subset of consultants access to these GPT tools, and they gave another set of consultants just the task to do on their own. And they tried to give the consultants a diverse set of tasks, from, let's say, doing kind of financial analysis to coming up with a set of new ideas for a fictional client. And what they found was that in the certain very basic tasks with a clear right answer, the consultants with the GPT did better. They were faster, they provided higher quality results. But then when they gave the consultants slightly more creative tasks that required a little bit more cognitive work, the GPT was able to provide results, but the results were less accurate, and the consultants actually performed worse when they relied on the GPT. So this was like essentially the false trust that consultants put in in these tools that led them to perform worse than their colleagues who didn't use the tool. And the interesting piece was that the authors of the study couldn't quite differentiate what made the tasks what they call inside the frontier, meaning something that generative AI could handle and could do really well, versus outside the frontier, something that generative AI couldn't handle and actually led those using it to perform worse. So this is another cautionary tale where it's not always clear when these tools might be useful or when they might lead to a false sense of trust. So it's not like there's a specific universe of use cases that are like, this is definitely what it can and can't do. Unlike, let's say, robotic process automation or industrial robots, where it's kind of clear what these tools can and can't do. Those boundaries are less clear, it seems. And I'd love to hear colleagues who are working on this, how you've encountered this, since it's kind of something that we're trying to puzzle through right now. Okay, I want to come back to something I said at the beginning around shaping the future of these technologies. So it's not inevitable how this set of technologies is going to play out. I think there's one possible future where generative AI tools look like apps on your phone, where there are a lot of different specific applications you can use them for. One of my favorite examples is Google Translate, which uses AI and has become much better incrementally over time and is incredibly useful. And there's another potential future where these tools look something like a system that is threaded through everything that we do and is something more like the electric grid. And in that possible future, I think there's, we might consider this a general purpose technology that has big impact on the economy. And thus far, I think that if we just look at this plot, we could think about the trajectories this way. Given the limitations that Patty talked about and that are widely accepted, the path up and to the right to become more flexible and much more reliable is just not going to happen unless you overcome those barriers that Patty outlined. The lack of explainability, the hallucinations, the inability to trust this system, right? In high stakes scenarios, it's just not going to be adopted. It's not going to have the reliability. But I do think that there are, and we've seen companies start to do this, there are ways of essentially moving up and to the left with generative AI, sacrificing some flexibility in exchange for reliability. So some companies are using vector embeddings or other restrictions on their models to control the type of content you can give the algorithm and also control the type of content that the algorithm gives back. And this just kind of creates a more reliable setting, but also limits what you can actually give to the model. So that creates an environment much more like your classic productivity tools. But also, there's a possibility that we create even more flexible settings. But this, to me, seems more like an app environment where you have some apps that are maybe lower stakes but highly flexible, and other apps in an enterprise environment, in a business environment, that are designed to be reliable. And here's my Salvador Dali painting of the hallucinations, but I think Patty went over that very well. And we also are interested in this area of explainable AI, and I'm happy to go into it further. But I really saw the list of questions, which were terrific, so I'd love to spend some time going through them if that's okay. Thank you very much.
All right, thank you very much, Ben. So we have time for questions before we break. So I'll let you read the first one, the one with the highest votes.
Okay. Anything new under the sun? Well, I do think that the skill piece is new. One thing that I didn't take the time to emphasize. So since about 1980, technological change and automation has been associated with the decline of the middle class in the United States and the EU. So the hollowing out of the middle is a function of a lot of things, outsourcing, some social policies, but there is a role that technological change has played. And the reason that it's played a role is because this technological change has been complementary to skilled individuals. So it's really been advantageous to people with a college degree, but not those without a four-year degree. And the hope among some of my colleagues in particular is that this set of technologies will have the opposite effect. Instead of being skill biased, it will be biased toward those who are less skilled. I see the results, for example, that it's lifting people up to the median. Essentially, it's performing as a boost to the bottom. But I don't think that actually plays out in an enterprise environment. I think, particularly if you look at experiments in coding, that the huge productivity benefit of Microsoft Copilot, for example, goes to someone who's the senior software architect and knows what the end product should look like and can use these tools to get there. So there's still a real advantage to mastery that I think will make this set of tools skill biased, but perhaps in a slightly different way. I see, replacing professors, maybe particularly at MIT, with AI, so they perform better. I wonder if that's a comment on my performance. I'm sorry if it is. I think that there's a question of how much we can automate teaching, particularly with. I was right in the middle of teaching in this transition to Zoom over during COVID, and one of the main things that was I think the students got all the content fine, and we actually found better ways of delivering the content with technology, but the mentorship and the kind of personal trying to understand what a student's interests are and how what we're teaching them is translating into their career and feeding into their life, that really was missed. And I think that those personal interactions with students are still lacking a little bit, even several years after. Companies working on AI implemented in robotics that change automatic. Okay. Interesting. So this is an active topic, is how to use, I would say, the different AI models being used, like for path planning and robotics, for example, not quite ready for prime time, partly because it's very hard to make this work in a production environment. To be able to redeploy robots flexibly. So one example is that a flexible way to teach a robot to do something would be learning by demonstration. So you'd essentially take the robot arm and show it how to perform a task, and then it would replicate that task. And my colleague Julie Shaw in her lab has done this, where you can learn by demonstration, and then you can actually teach the robot. You could interrupt the robot. So you have a person who comes into the robot space, and the robot learns how to avoid them and still complete the task. And that's a very exciting research. It's actually featured at the MIT Museum, but it's not ready for any production environment, in part because the robot, if interrupted, will oftentimes stop, and it's still not robust enough to do a high volume manufacturing task. But we do work with a lot of manufacturers to help them troubleshoot how to make their robots more flexible. Part of that is just a skill question. If you have someone skilled enough on the factory floor to redeploy and reprogram your robots, that's the right person. The challenge is they need to know how to do the programming, but also know your production processes really well. And it turns out the production processes are often harder to learn than the programming, given there's been a lot of investment in easy robot programming.
So let's take one more question.
Great. Implementing training on ChatGPT to employees of a corporation. So this is a great question, partly because this is something that we're working with a training partner on doing for the companies in our working group. So I think that the key challenge here is bridging what we think of as like technical knowledge or knowledge of how a tool works and how to use it most effectively with process knowledge of how to really perform the task well within a business environment. And why automation is so often hard to scale is that the technical knowledge and the process knowledge in a company are residing in different teams. So IT might have the technical knowledge, and then process knowledge might be among business leaders. And finding people, individuals in particular, who can merge those two sets of knowledge is exceedingly rare. So part of the training, I think, can focus on process experts and bring them a little bit more into the world and knowledge base of the IT community. Thank you.
All right. Thank you very much, Ben.